A store sells packages of red pens and packages of blue pens. Red pens are sold only in packages of 6. Blue pens are sold only in packages of 9 pens. Igor bought 5 packages of red pens and 3 packages of blue pens. How many pens did he buy altogether? So this would be 5 times 6 plus 3 times 9. And that, I believe, is 57. Robin bought 369 pens. She bought 21 packages of red pens. How many packages of blue pens did she buy? So this equation would be 369 is equal to 21 times 6 for the red pens. But I'll just put B to represent the number of packages of blue pens, and each package contains 9. And that's it. You got to solve this equation. And that's fairly straightforward. I believe it's 243 is equal to 9b. And therefore B is going to be 27. Explain why it is not possible for Susan to buy exactly 31 pens. I don't know who Susan is, but let's see. Well, the formula, if it was possible, would be 6r plus 9b. And that would equal 31. Now this side here, you can factor out, I believe, a 3. So that would give me 2r plus 3b. And this is 31 a prime number? I think so. So now you have a little bit of a paradox. On this side, you've got a 3. So that means that this whole side is it's divisible by 3. Obviously, I factored out a 3. But this side is a prime number, and this is not divisible by 3. So one side is a multiple of 3, one side is not. So therefore, this could not happen. There's no way. So you can explain that in words because that's what this symbol means. You know, one side is clearly shown to be a multiple of 3 and one side is a prime number, and therefore those two cannot be equal. By finding a common denominator, we see that 1 over 3 is greater than 1 over 7 because 7 over 21 is greater than 3 over 21. Similarly, we see that 1/3 is less than 1/2 because 2 over 6 is less than 3 over 6. Determine the integer n so that n over 40 is greater than 1/5 and less than 1 over 4. Common denominator is the key here. So I guess what we're really setting up is this kind of story where I have n over 40, and they're saying that it's greater than 1 over 5, and then it's less than 1 over 4, I believe, right? Yeah. Okay, so then common denominator, I guess in this case, would just make everything 40. So that one stays n over 40, and then multiply top and bottom by what, 8 on this side. So this will be 8 over 40, and multiply top and bottom by 10. So this is going to be 10 over 40. Okay, well, that's pretty. Now we can just eliminate the denominators, and then you just have the numerators. And I guess at this point, it's pretty straightforward as to what n is. Since n is an integer, the only integer between 8 and 10 is n equals 9, of course. Determine all possible integers m so that m over 8 is greater than 1/3 and m plus 1 over 8 is less than 2/3. Right. So same story. Let's see here. We got m over 8 is greater than 1 over 3. So I think this one I guess I could just treat it independently, maybe. Just getting a common denominator here. So multiply top and bottom by 3, so that's going to be 3m is over 24 is greater than multiply top and bottom by 8, 8 over 24. So that basically means that 3m is greater than 8, so m is greater than 8 over 3, and 8 over 3 is approximately 2.66, I think. So m is greater than 2.66. So that's about as far as I can go with that guy. And then the next one, they tell me that m plus 1 over 8 is less than 2 over 3. So same story here. You can actually cross multiply. You don't even have to do this common denominator stuff. That's sort of the what they want you to do, but you can do it anywhere you want. I can just cross multiply. 3m plus 1 is less than 16, and then 3m is less than 15, like that, if I did this correctly. Or actually, I think, yeah, 16 and 3m plus 3. Sorry, yeah. You got to make sure I do the math correct. So that means 3m is less than 13, I believe. Yeah. And then therefore m is less than 13 over 3. And in terms of a decimal, that's 4.33, I think. 13 over 3, right? Okay, so combining these two guys, you get that m is less than 4.33, but greater than 2.66. And m is an integer, I believe, right? Yeah. So the only integers in that range would be 3 and 4. Fiona calculates her win ratio by dividing the number of games that she won by the total number of games that she played. At the start of the weekend, Fiona has played 30 games with W wins. Her win ratio is greater than 0.5. During the weekend, she plays 5 games and wins 3 of these games. At the end of the weekend, Fiona's win ratio is less than 0.7. Determine all possible values of W. Okay, so W over P, I guess, is the story. And in our first scenario, it's W over 30, and that is less than a half, according to their question. So very quickly, we can get that W is, hold on, sorry, this should be greater than, right? Yeah, greater than. So that very quickly, we get that W is greater than 15. Okay, so that's the first part. And then the second part, this whole thing about the weekend, is that we have 3 more games that she wins, but she played 5 more games. So instead of 30, it's 35 this time. And that is less than 0.7, so 7 over 10. And then we can just cross multiply here. So that's going to be 10, whatever this is, 10W plus 30 is less than, whatever that is, 245. And then do some math here. 10W is less than 215, so therefore W is less than 21.5, I believe. 21.5. Okay, so then combine these two guys, and therefore W is greater than 15. Or actually, I'll write it this way: greater than 15 and less than 21.5. And is W an integer? Yeah, because it represents the number of games that she won, so obviously it's an integer. So that means W can be either 16, 17, 18, 19, 20, and 21. So there you go. Number 3, when 2 chords intersect each other inside a circle, the products of the lengths of their segments are equal. That is, when chords P, Q, and RS intersect at X, Px times Qx is equal to Rx times Xx. In figure A below, the chords G, D, E, and FG intersect at X, so that Ex is 8, Fx is 6, and Gx is 4. What is the length of Dx? According to our formula, that's going to be Dx times 8 is equal to 6 times 4, and therefore when you solve this, Dx is 3. Part B. In figure B, the chords JK and LM intersect at X. Jx is 8y, Kx is 10, Lx is 16, and Mx is y plus 9. Determine the value of y. So same story. It's going to be, let's see here, 8y times 10 is equal to 16 times y plus 9. So cross multiply, and we get 80y is 16y plus 144. And therefore, that's what, 64y is 144, and therefore y is 144 over 64, which I believe is 9 over 4 in lowest terms. C. In figure C, chord ST intersects chord PQ and PR at U and V respectively, so that PU is M, QU is 5, RV is 8, SU is 3, UV and PV is N, TV is 6. Determine the values of M and N. So we got to do a double one this time. A double calculation. The first calculation involves 3 and n plus 6. So this line and then this line. So we got 3 times n plus 6 is equal to m times 5. Wait, do I have the right letters here? Yeah. So this is 3n plus 18 is 5m. And do I know anything in this question? No. So I guess that's as far as I can go there for now, and then I guess I have to do something else. And what else can I use here? I can use this line, that line, and then this line again. Okay, so that's going to give me n times 8 is equal to 6 times n plus 3. Okay, I got it. So this is going to be 6n plus 18, so therefore 2n is 18, so n is 9. Okay, and then I take that n equals 9 and put it back into here. So that's going to be 3 times 9 plus 18 is 5m. So I believe that is 27 plus 18, which is what, 45? 45 is 5m, so m is equal to 9. So n is 9 and m is 9. They want the values of both m and n. Three students sit around a table. Each student has some candies. And the following procedure: step 1, each student with an odd number discards 1 candy. Step 2, each student then passes half of their candies. And then step 2 and step 1 are repeated. On Monday, Dave, Yona, and Tam start with 3, 7, and 10 candies. And after step 1 and step 2, the number of candies is as follows. When the procedure in the example above is completed, how many candies does each student have? So we are going to start here and off we go. So we got Dave, Yona, and Tam, and we got 6, 4, and 8. So let's work through this, and it's a bit cumbersome, but hopefully once you go through it once, it'll be easy. So I'm gonna do it sort of the real explanation way, kind of draw out the diagram and sort of explain it in detail. Okay. So the first step is, of course, is there anything odd? And there's no odd numbers. So the first step where you take away 1, that doesn't happen. The next thing that happens is where you have to give half. Each person has to give half, that kind of story. So we started with looks like 6, 4, and 8, right? So when you give half, that means D is going to give 3, Y is going to give 2, and T is going to give 4. So when this all happens, D is going to be they gave away 3 and then gained 4, so that's plus 1, so 7. And then Y gave away 2, knocked it down to 2, but then gained 3, so went back up to 5. And then T started with 8, gave away 4, knocked it down to 4, but gained 2, so gained back up to 6. So you see, that's how we get this number. And you just got to keep going like that. It's just, that's all it is, really. Okay, so now, is there anything odd? The answer is yes. So if there's odd, you get rid of 1. So the 7 drops down to 6. 5 drops down to 4. The 6 remains the same because even you don't do anything just quite yet. You just got to take care of that odd numbers by getting rid of 1. Okay, so now we're at 6, 4, and 6. And same kind of story, D, Y, T. And then these guys, looks like it's 6, 4, 6 this time. So 6, 4, 6. And then now, because they're even, we got to give away half. So this has got to give away 3, 2, and 3. So let's see what the new numbers are. Let's move this up a bit. So D doesn't change. D remains at 6. Y lost 2, gained 3, so that's 5. And T lost 3, gained 2, so we're down to 5, I believe. Got it? Okay, so now we have some odds, so we got to use that rule, which is take away 1, so this drops down to 6, 4, 4. Okay, so I'm going to do this again, so here we go. Again, same kind of story. We're starting with, what is it, 6, 4, 4 this time? Yeah, 6, 4, 4. Okay, so again, we got to get rid of 3 here, 2 here, 2 here. So D this time got rid of 3, but gained 2, so it drops down by 1, so it gets 5. Y lost 2, gained 3, so it goes up by 1, so we're up to 5 there. And then T remains the same because lost 2, gained 2. Okay, 5, 5, 4. But now we got to do that rule that when they're odd. So this drops down to 4, this drops down to 4, this remains at 4, and there you go. This is when the game ends, when they're all equal. And that's what they're asking. How many candies does each student have when the procedure ends? The procedure ends when they have an equal number. That's when the procedure ends. And this is, of course, an equal number. And they're saying, well, how much do they each have? And the answer is 4. On Tuesday, Dave starts with 16. Each of Yona and Tam start with 0. how many candies does each student have after the procedure ends. So this time we are given a little bit different numbers, of course. It's 16, 0, and 0. And we have to go through this procedure. Now, I'm just going to go through the first few because, I mean, it's very, very, how you say, cumbersome. It's just the same thing over and over again, so you don't really need me to talk you through everything. But I'll just do the first couple, and then I'll give you the numbers, and you can figure it out. So we started with 16, 0, and 0, right? The first thing is there anything odd? And the answer is no. 0 is actually considered an even number, believe it or not. So we got to get rid of half because we're dealing with even numbers. Well, half of 0 is 0, and so is that 0. So immediately this gets knocked down to 8, and then y, I believe, picks up 8, and then t doesn't pick up anything. So it's 880. Okay, I'll do one more. D, y, and t. So same kind of story. Okay, so now we're at 8 and 8, right? Okay. So this is going to, well, first, is there anything odd? And the answer is no. So then we just go to the even rule, which is you get rid of half. And that's going to be 4, 4, and 0. So what is it now? D got rid of 4, so we're knocked down to 4. Y looks like y stays the same. And then t gains 4. So now we're at that, 484. And then you just keep doing this. So when you do, you get the following. You get 4, 6, 6, 5, 5, 6, 4, 4, 6, 5, 4, 5, and then finally 4, 4, 4, and that's when the game ends. And that's when you know the answer is 4. So same kind of story. On Wednesday, Dave starts with 2N candies. Each of Yona and Tam start with 2N plus 3. Determine with justification the number of candies in terms of N that each student has when the procedure ends. So a little bit different this time. Same kind of concept, but instead of numbers, they're giving you N's. So we got 2N, 2N plus 3, and 2N plus 3. Okay, we can do this. I don't think this is a problem. First thing is that the odd rule, and this is even, but this is odd. So you got to get rid of 1 from the odds. So this drops down to 2N plus 2. Got it? And then same kind of story. We got D, Y, and T. And then we got to give half away because now all these 3 numbers are even. So half of D is going to be N, half of Y is a N plus 1, and half of T is N plus 1. Right? So then you calculate this. So D was at 2N. You got rid of N, dropped it down to N, but then gained N plus 1. So this becomes 2N plus 1. Y got rid of, well, you're at 2N plus 2, got rid of N plus 1, so that drops it down to N plus 1, and you got N. So it becomes 2N plus 1. Okay. And T stays the same, I believe, 2N plus 2. Okay, great. Now let's look at it. Is there anything odd? The answer is yes. These 2 are odd, so you got to get rid of 1 from each of those. Okay, we did that. And then now what? No, and now they're all even, so we got to go through this big long song and dance again. All right, great. So we got to get rid of half of each. So 2N, that's N. Half of Y is N, and half of T is N plus 1. Okay, so this drops down to N. Wait, hold on. Wait. Let me make sure. D gets rid of N, drops down to N, but then gains N plus 1, so drops up to 2N plus 1. I got to make sure I do it right. Y stays the same, so that stays 2N. And then T gets rid of 1, so that becomes 2N plus 1. Okay. All right, so now do we have any odds? The answer is yes. These 2 are odd. Get rid of 1, so this becomes 2N, this becomes 2N, this remains 2N, and that's it. We are done. All 3 are the same, and that means the procedure ends. And how many candies do they have? Well, each of them has 2N candies when the procedure ends.